what we're basically looking at is objective 1. So module 1, objective 1, and that's basically some terms that you need to understand in terms of digital media. So in the context of digital media, some terms that you need to understand. We already looked at what is digital media. We looked at alternative terms to digital media, professionals in digital media, why are we studying digital media, institutions that you can go and study further, and then we started some terms, audio, bandwidth, and so now we're going to be looking at broadband. Let's see. Alright, Atavia, can you read that for us? What is broadband?
What am I reading?
What is broadband?
Broadband, high capacity transmission techniques used in a wide range of frequency, which enables many messages to be communicated simultaneously. Broadband popularly can send data in voice data and video through the same media or communication channel. Example, the coaxial cable.
Alright, good. So, do you have, and do any of you have an idea as to what is broadband? And I'm pretty sure you've heard of that term before, broadband internet. But do you have any idea as to what does that mean?
More data transmission capacity.
Good. More data transmission capacity. Good. Anybody else?
Could it be that the data is transmitted faster?
Yes, that too. Broadband also means that the data is being transmitted faster. What you can do anytime you're looking at something in terms of digital media, try to compare it to technology, similar technology in the past. So the term broadband usually is referring to internet, the internet connections that we have today. So compared to internet connections we had before, as you guys mentioned, the transmission capacity is higher. So, well, the definition mentioned it. So higher transmission capacity. Higher transmission capacity. It has a wider range of frequency. What does that mean? Last week we were talking about frequency, or the previous week. What does this wider range of frequency allow us to do?
It could get access to more than one thingamajiggies at the same time. This is the best way I can explain.
Somebody want to help her? You're heading in the right direction, but we're looking for the right term. It allows a wider range of what?
Of data transmission?
Something more specific I'm looking for.
Wider range of bandwidth.
Wider range of bandwidth. Not exactly that. What does having more bandwidth, more frequency allow you to have? Shanti or Rima? You're doing IT, you're supposed to know this.
Um, I think like a wider range of frequency means like more, like a better quality, or like more signal being put out there, I guess.
Yes, everything you guys saying is correct, but looking for something very specific, something that happens when you get a wider range of frequency. And we actually learned it last week. What does having more frequency range allow you to get or to do? It allows you to send what? More types of data or less types of data?
More types of data.
Yeah. So if you can remember this diagram that we were looking at last week, because we have a wider range of frequencies, say for example 1 gigahertz to 12 gigahertz, say that is our range, we're just using this as an example. We can send different types of data. We can use 1 gigahertz to send a particular type of data, 2 gigahertz to send another type, 3 gigahertz to send another type, 4, 5. They're all being used to send different type of data across this one communication channel. So say for instance you have one cable that's coming to your home, and that one cable has a range of 1 gigahertz to 12 gigahertz. We're just using this as an example. With that cable now, they can send different types of signal at different frequency. So that's what's meant by broadband. That's what's meant by having a wider range of frequency. So a wider range of frequency allowing different types of data. And if you look at the paragraph that you guys just read, it says which enable many messages to be communicated. That's basically the same. That is a simplified version of it. Many messages, many types of data, same thing, same difference. And it even mentions it in the next line. What types of data does it mention? What type of data does broadband allow you to send?
Video.
So for example, voice, data, and video. Those type of data and any other type of data, it will allow you to send at the same time. Now you have to compare this now to narrowband. If you guys can remember narrowband has less bandwidth. So that's this line that you see going up here. That's less bandwidth. So only a limited type of signal could have been sent. Now because broadband has a wider range, it can allow you to send different types of data. So that there is the difference there between the two. Alright, you guys clear on that? Communication modes.
Yes, sir.
So next we're gonna move on to communication modes. Alright, Arima, you can read communication modes.
Yes, sir. Alright. Communication modes. Simplex. Data is transmitted in one direction only. Example, TV, radio. Duplex. Data is transmitted in two directions, sent and received at the same time. Example, phones. Voice over Internet Protocol, VoIP, etc. And half duplex, data is sent in both directions but not at the same time. Citizens bands, CB, radio, used by taxi and police, walkie-talkie, etc.
Good. So in your own words, what does communication mode, now talking about the type, what does a communication mode refer to? What does it basically refer to? What would you say it refers to? Based on everything that you have here.
Like the directions that data is transmitted.
Good,
It's the
very
types
good.
of refer to that.
Good. Referring to the direction of data flow. That's basically communication mode. The direction of how data is going to flow. So the very first one, we have simplex, and that's only one direction only. So whether it's either from sender to receiver or receiver to sender, whichever direction, but only one direction only. Now next we have um, half duplex. So that's going to be both directions, but only one at a time. So for example, you have a walkie-talkie. So all of you know how a walkie-talkie works, right?
Yes, sir.
Yeah, so one person speaks and the other has to listen, and you cannot both speak at the same time, because anybody know what happens when both persons speak at the same time?
One just overpower the other one.
Not sure about that, but I know they usually clash with each other. The two signal would clash with each other, and it would cause a distortion, it would cause a noise. So no, none of them would be able to hear. So that is why it can only go in one direction. So that's why when using a walkie-talkie, you would usually have to wait for the, one person to speak, so that that transmission is clear, and the other person would be able to listen and then respond. And then we have full duplex, which is transmission of both directions at the same time. So that's basically what we're using today. We're using full duplex as we communicate, as we use the internet, as we use various network. We're using full duplex communication. Now, is one better than the other? Just because full duplex can send in both directions at the same time, is that better than the rest?
Yeah.
You could say so, it is. But, because you get to send data in both directions. But, would you always use full duplex communication?
No, I don't think so.
So, for example, if you're listening to the radio, you're watching TV, would you do you think it's full duplex would be the best type of communication mode, or is it necessary to have full duplex?
Like specifically for the radio?
Yeah, for radio and television.
No.
Why not?
Because if I talking and they talking, I think I'll get like a clash.
Mm, but the question is, alright, ignoring the part with the clash. The question is, when the radio is sending out their signal, the television is sending out their signal, do they need you to communicate back with them?
Oh no.
No. So that answers the question there. The radio channel, the television channel, they don't need you to communicate back to them via that communication channel. So that signal that they're sending out for you to receive the radio, to receive the television, they don't need you to send back a message via that same communication method. So, if you understand what I just said, then that doesn't mean one is better than the other. What it means is that each has their own benefits, each has their own role to play. So in certain situations, simplex is going to be the most effective method of communication, and in other situations, full duplex is going to be the most effective method. Did you guys clear that?
Yes, sir.
Alright, so moving on to our next term. So our next term is the word capture. And Janaya, could you read that for us? Alright, it's a simple line. So capture says to collect, gather, access information for digital productions. Have any of you ever heard that term before? No?
Yeah.
And what does it mean to you? Before you've read this definition here, what did the term capture mean to you? Anybody?
Um, Catching something.
Okay, so that kind of capture you're talking about. But you can think of it that way also. Um,
To seize.
the C's. Okay.
Like where it's like take like a picture, seize in the moment, or you catching somebody.
Okay, good, good. So, would you say when you're taking a picture, you're capturing something? Would you use that word capture?
Yeah,
Good.
you're capturing the moment.
Right. So that's a good example there. So, capture, as the definition here indicates, it's to collect information or data. It's to gather information or data. It's to access information or data. So, an example would be, um, for example, taking a photo. We would use the word capture. So, capture can indicate taking a photo or a video. So whenever using a camera to take a photo, to take a video, we can use the term capture to indicate that we are recording a photo or a video. Now, there are other methods that you guys actually capture data. What are some other methods that you use to capture data?
Voice recordings, for example, like if you're sending a message in WhatsApp or so on.
Good. What are some other examples? You guys use it a lot for your IA and SBA.
Mister?
I said you guys use it a lot for your IA and SBA.
Questionnaire.
Mm-hmm. Questionnaire. What else?
Interviews.
Interview.
Mm-hmm. What else? Is Shanti there? Because I'm not hearing from her at all.
I am.
Yeah, so it's an interactive class. So it's recommended that you participate. Yeah, in addition to interview, questionnaire, one more word.
Survey.
Survey, good. So all of those are methods of collecting data. And we can use the term capture to indicate that we are capturing that data. We are recording that data. So to collect, we can also use the term record. So to record, collect, gather, access data slash information for digital production. Good. So that's what the term capture means. Now, what does the term content integration mean? Janai, you can read that one.
Content integration, information and data in several formats presented as one. Example, Building a PowerPoint can include several formats of information or creating an edited video.
So, was that definition clear?
Yeah.
So, basically, you're taking different forms of information, different forms of media, different formats of them. Now, when we say formats of media, formats of information, anybody has an idea of what does that mean?
Sir, put that over, please.
So, the definition says here that we are taking different formats of media, different formats of data, different formats of information. What does that mean? What formats can information and data be in?
Like
Numbers, words, graphs.
So you said numbers, words, graphs. Anything else?
Pictures.
Mm-hmm. So I'm looking for terms more in terms of digital media. So, um, so for example, pictures. What else? Graphs. What other format do we have of information and data in terms of digital media?
Videos.
Video, text. What else?
audio,
What was that, Arima?
audio,
Audio. Good. So those are some examples of formats of information and data. Now, so what we're gonna do is take these various formats, pictures, graphs, video, audio, text, and present them as one. That is what's meant by content integration. So a very common example that you guys use is Microsoft PowerPoint. A very simple example. You take an image, you take some words, and sometimes you even add some audio, and you present it as one file, as one content, that PowerPoint presentation. So that there is content integration. Even a video is content integration, because a video, you would combine videos together, you would combine audio, various pictures and text and so on, and you make it into one video. So that's what's meant by content integration. You guys clear enough?
Yes, sir.
Alright. So our next term is convergence. Shanti, can you read that for us?
Conversions coming together of various technologies and formats of data or information for production purposes. Note one's final product has been integrated or converted. If there must be any corrections or changes, then the source has to first be adjusted and the process of conversions and or integration done again. Example rendering of a video file after taking inputs of videos, graphs, text, sounds, images, etc. Or converting a file to portable document format, PDF type, file type.
Great. So convergence is somewhat similar to content integration. You're combining various media, various data, various form of content, pictures, images, graphs, and so on, into one final product. So like how you would take various images, audio, and so on, and you would combine it into a video, or when you save your Word document, you save it as a PDF, But what happens is that you can't go and edit that final document. So you've created as a video, you create it as a PDF, but not everything you can change. You can make a change to. Yes, the video you could still change the audio. You could do some edits afterwards, but sometimes it won't allow you to control everything, to edit everything. So what basically happens is that you have to go back to the original, make your necessary change to the original content that you would have been using to create this PDF or video, and make your change to that, and then you basically combine everything together and you get back your final file. So you guys know that unless you um, paid for Adobe, you can't really edit a PDF, right?
Yes, sir.
Good. So that's basically what is meant here. Pictures, video, graphic, images. Do you guys know there's a difference between graphic and image? Anyone know if there's a difference?
I know that there is a difference. I just don't know what the difference is.
Alright, so images are more of like it's like a slight difference. Images are more of realistic um, scenes. So like an image of a person, a landscape, a building, a house, a computer. Those are images. So image is something that is real, something that's existed. You can see it, like a picture of something. Whereas a graphic is something that somebody's going to go and create. So, like for instance, they're going to go and create a logo, they're going to create a poster, they're going to create some form of clip art. Those are termed graphic. But the terms are could kind of be used interchange, because obviously persons call logos images and so on. But it's just a slight difference between the two. So that's why you have job positions such as graphic artist, and then you have photo editor. So that differentiates their position. So the graphic artists, those are going to be working more with graphics. So they're going to be the logo designer, the posters, the flyers, and so on. Whereas a photographer that's going to be doing photo editing, he is going to be more into taking photos and editing those photos of real world scenes and so on. So it is a slight difference between the two then. Alright, so if you guys following so far, any questions so far? No questions? Alright, so moving on to compression. Arima, you can read that.
Compression. Making file size for storage much smaller than their actual file size. Example, WinRAR, zip, and 7-zip. Traditionally, when multiple files are to be sent, the files can be placed in a folder on the storage media and the folder is compressed. The compressed file is what is transmitted via email.
Good. So have any of you ever compressed a file?
Yes, sir.
Yeah.
Yeah, it's very simple. You go to a group of files or folder, whatever you want to compress, and Windows actually makes it simple. You actually don't need actually it's been like that for a while. You actually don't need a special software. You just highlight the files, and you go to Cento, and the option is right here, compress zip folder, and you simply select this option, and it compresses it for you. You give it a name, and it compresses that file into those files into a zip file. So compression has roughly 2 benefits that I can think of. If you can think of more, you can let me know. So one of the major benefits is to reduce file size. So making file size storage much smaller than their actual size. So one of their main benefit is to reduce file size. Now, what are some reasons why you would want to reduce file size?
Storage.
For storage, good. So you can reduce the amount of storage. What else? Can you think of anything else?
It's easier to send as a compressed file because it can take up less megabytes or whatever those things are.
Very good. And that's what I was looking for. So, so benefits, we have smaller storage and easy to transfer. It makes it easy to transfer. So, if you think about it, say for instance you have 100 photos that you want to send to somebody, instead of sending each photo individually, compressing it and sending it as one large file is actually going to be easier. Because you know when you send a lot of files, what tends to happen is that maybe one or two gets something happens with the file transfer and they don't send with the rest of files. So they basically and then you gotta keep retrying to send that file and so on. So sending it as one large file can ensure that the person gets everything. So that's two benefit there of file compression for reducing file size. Now,
Oh. And when like a bunch of things are coming into your device at once, it can cause it to freeze.
right,
And
right, that can happen. So, and that happens because the device has to process each file individually. So, and that's actually how um, IT students, when you send a lot of files to a device, what is that? What does that lead to?
Do that again, please.
When you send a lot of files to a device, what does that lead to? Because there are certain persons that do that willingly. They send a lot of files to a device.
It is crash.
Yeah, but what kind of there's a particular name for that kind of action.
Oh my gosh, I have it in mind. I just don't know what it is.
Yes, that's why I said IT students are supposed to know it.
Something with malicious something. I can't remember.
No, it starts with a D.
D.
D
DOS.
D what?
DDoS or DOS. DOS.
Me another one.
DOS and DDoS. You're supposed to know this.
I probably know it by this term.
Denial of service.
Wait, you teach me this? Like, did we
Yeah,
learn that?
in third form.
Oh,
And Arima would
oh.
have learned that last year for IT. And Shanti. Arima and Shanti, you guys remember this?
Pardon me, no.
I
Y'all
don't
didn't,
remember anything like that.
y'all didn't learn this? It's a
I
type.
don't remember doing nothing like that.
It's a type of security vulnerability. Y'all didn't learn about security vulnerability. What's the rest? Computer viruses, phishing.
Yeah, I know phishing, but like I don't remember the denial of service.
Yeah, denial of service is one of them. So denial of
You
service.
sure you can do it in Terraform?
Yeah, let's start farm work.
Oh,
Um, So denial of service, one method of denial of service is when you send a lot of files to a computer or device, and that device basically has to process all of these files individually. So imagine if you send thousands of files, you keep sending thousands, hundreds of thousands of files, it has to process all of those hundreds of thousands of files, and when a legitimate person that comes to actually use the service, they cannot. Why? Because the system is basically busy dealing with all this junk information. So that's called denial of service. So going back to what we're talking about, compression. So that is why your phone actually slows down when somebody sends you a lot of images, somebody sends you a lot of file. Even your computer, it can happen too, because your computer, your phone, your device, it has to process all of this information, and if it's too much, obviously it's going to slow down, and if it's too much for it to handle, it's basically going to crash. So going back to what we're talking about, file transfer, compression, that's actually, you could say that's actually another benefit there. So it easily transfer by allowing you to send one single file, which is going to help reduce an overload on the device. So you can say it helps minimize denial of service. Good. So file compression, easy to transfer. Was that everything? Yeah, that's everything. So that's the main two benefits there: file compression and the ease of transfer. Now, does anyone know how file compression works? That's the next thing. How does file compression work? Anyone? These are simple IT questions that IT students are supposed to know.
Sir.
So
Yeah.
I'm not an IT student.
But I done, right? I finished writing 1998.
I'm attacking the two IT students that we have here.
Is that necessary to do that?
Yes, it is.
There is it's like when how you do telling me in Microsoft Access, similar to that, like reducing if you have your data type is like text, I believe it's in Access. Yeah, text, right? You would have a certain amount of letters or characters that you can assign to that data type, right? But you can also set it to be like only 6 characters, right? So you're reducing the space. So it's just like that. Like when files compress, it's like when it's scanned or so on, it like kind of just picks out what is like repeated or so on, and just puts like something there to just like identify it uniquely, I guess. And it doesn't have a repetition of that, and unnecessary spaces one, it just takes it out.
Yeah, that sounds somewhat correct. Somewhat what happens with compression. Now, there's different forms of compression. There's different types of compression. If we were to Google types of compression, we have a variety of compression. So that's the felt type. What am I looking for? Anyway, so let's not go into that. Yeah, there are different types of file compression. So basically, that means there's different methods of carrying out compression. But a simplified version of it, a simple version of explaining how compression works, is this way. So we know that all data on a computer is in what format?
In computers?
Yeah, so binary, right? So all data in computers are in binary. So say for instance the computer has a file has this binary number. Now one way that's a perfect line, wow. Yeah, one way that a computer can carry out compression is by reducing the amount of like combination of zeros and ones. So say for instance like how this combination of 0 is together, then it can replace this with 1 0. So it might be something like 1 0 1 1 0 1 0 1 1 1 and put one single 0 there. And it might have a table somewhere that would indicate how much 0 has to go back here. So what it would basically do is try to look for similar data, similar matching data that it can take out, and it would keep like a table to indicate that I took out a piece of data from here and I took out a piece of data from here. Both of these are basically the same. Just using this as an example. Just say both of these are the same, and it's going to take out these two, put one of it into a table, and just use some small piece of information, like for example this here. Just use some small piece of information to represent it, and thus reducing the file size of that file. So a simplified version of compression is that it looks for similar data, look for similar patterns of data, and try to take out those similar data, replace it with something that can represent it, so thus reducing the file size. Think you guys understand that?
Yeah.
Rest of you?
Yes, sir.
Now,
Yes, sir.
you ever notice that, so the question is, how does compression work? One example is by replacing similar data. That's just a simplified version of it. Now, you ever notice that when you compress certain files, the file size does not reduce? That one?
No, not really, because I don't compress files to like a lot.
So, certain files, when you compress them, when you try to compress them, the file does not reduce in size, or it might barely go down by a little bit. And then you got certain files, when you compress them, you see a whole difference in file comparison. One is the uncompressed is very large, and the compressed is very small. So the reason why certain files, when they compress, they don't reduce file size, is simply because it does not have any data that it can take away from the file. All the information there is necessary to have to read and understand that file. So if it takes away anything, then the file might basically become corrupt. So instead of saying take away, we can replace it. You can see one example is by taking out similar data. That more accurately represents what is happening. So it takes out similar data. So if the file does not have any data that it can take away to reduce the size, then compression won't reduce any file size. So that's why certain files Even though they compress, they do not reduce their file size. So, with all this information, can you guys tell me, is there a disadvantage of reducing of carrying out file compression? Is there a disadvantage based on everything that you just said?
Is there any such thing as a file being too large to compress?
Um, I don't think so. No, I don't think so because all files should allow you to compress them, unless the software has a limit on the file size. But that's not the disadvantage I'm looking at. We're still talking about how compression works. Now, compression works by taking out similar data. So, is there a disadvantage to that? Think about it. Is there a disadvantage to that? If you take out data, what do you think is going to happen?
There's a possibility you won't get back the data.
Good. So that's one possibility. It could have. Um, but I'm looking for something more specific. Could damage file. So that's one possibility. It could damage the file. So when you take out this data, it might take out something important and it might not know how to put it back together. But that's a rare possibility because the software should be able to know. But that's still a possibility. It could damage the file. So what else could happen? Something in line with damaging the file. But instead of completely damaging it, what could happen? Alright, let me give you an example. What could happen if you compress a video file, a music file, an image? What could happen to that
Can you
file?
like corrupt it?
Could corrupt it. Okay, good. Corrupt the file. Still looking for something else. Could damage the file, corrupt the file. What else?
Might produce some sort of like distortion to it,
Mm-hmm.
like all over the place.
Good. Distortion. And what I was looking for is a reduction in quality. So you still have the file. The file is working. The file exists and is working good. But you have a reduction in quality. Because remember, you're taking out data. And that is actually what happens today. We actually use files today with a reduced quality. So for instance, so for example, you have MP3. We all know what's MP3, right?
Yes,
Yeah.
sir.
So MP3 is a version of music file that we use to listen to audio. Now MP3, basically all file types, MP3, Microsoft .x, PDF, MP4, JPEG, PNG, all of those file types, they are all file compression. Every file type is a file compression. Every file type is a file compression because there are different methods of compressing the file so that it can be stored as a file. Now MP3 is actually a file compression that has a reduced quality. Now what I want you guys to Google quickly, let me see who can find it first. High quality music file format, and tell me what you get. High quality music file formats. High quality music file formats.
WAV.
Good. So you have WAV. What else? We should have more. FLAC. Good.
AAC.
AAC. Good. So those are all music or audio file compressions. They're all music and audio file types. But the difference between them is the quality. So compression actually is linked to quality. If you compress too much, you're going to get a reduction in quality. You're going to get a reduction in size. Yes, the file size is going to be smaller, but you're also going to get a reduction in quality of that file. So that is why these file types are usually called lossless audio. You guys ever heard of that term, lossless audio?
I just did on Google.
Yeah. So that basically means that the audio file has all of the data that whoever created that audio file, it has everything inside of it. So when a person is listening to this type of music, it has all the instrument, all the fine details of it. But that file type is going to be very large because it has to have all of this data inside of it. So since we do not like large files and we like the smallest file possible, that is why all of our music file is in an MP3 format. Because we as persons, we have small storage devices, thus we need smaller file types. So we make use of the MP3. And the MP3 is actually good enough for persons to listen to. It's not like if it's poor quality, like absolute trash, but it's good enough so that persons can listen to it. Now MP3 or for audio has what is called a bit rate. Anybody know what that is?
I just see that word a lot when I have to download stuff, but I just don't know what it means.
When you're downloading audio?
Yeah.
Yeah. And even when you're downloading video, it's gonna show up also. Which refers to quality. So bitrate refers to the quality of the file. So you ever notice that if you choose a higher bit rate, it's a larger file?
Yeah.
Right. So this all deals with file compression. Basically, once a file is large, it means it's storing more data. Obviously, once a file is large, it has more data. So that means, it usually means, not always, it usually means that file has a higher quality. So usually higher data size equals higher quality. This is not always the case because you have some devices, like for example a camera, that could record high quality video, but the video might be poor. Like for example those movie videos, when they come out, those camera versions of videos, those could be very large files, but the video quality is very poor. So that's why I'm saying usually. So usually, once the file size is large, that means it has a higher quality. So when you're gonna check for bit rate for a video or audio, you can notice, for example, you can notice bit rate such as 128 bps. Is it bps? I think so. 256 bps. Is it bps? Let me verify. Anybody can verify? Arima does read the see?
No, sir. I see something with a key.
Or kbps. It's kbps. Good. So these are some examples of what you would see. And obviously, the lower the bit rate is going to be lower the quality. So say for instance, if you're downloading music, if you download a 64 kbps bitrate audio, it's going to be a low quality. Now 128 is actually not, it's like middle ground between bad and good. A person who isn't all of that into audio, into music, they might not recognize that it's a poor quality, but if you're accustomed to good quality, you might recognize it. So, like for instance, myself, when I'm downloading audio, I would download at a 256 bit rate because that's a much better quality than the 128. But obviously, when you're going to download at that quality, it's going to take up more storage. Those music files are usually somewhere between 5 megabytes to 9 megabytes, depending on the length of the song. So, to summarize everything about compression, compression works by taking out files, taking out pieces of data, and by doing that, you can reduce the quality of the file. So that's how we end up with MP3, because MP3 is a reduced quality of WAV, FLAC, AAC, and so on. Now, when you're looking for music files, for example MP3, you can also look for like different versions of the MP3, which has different bitrate quality. So the lower the bitrate, lower the quality, higher the bitrate, higher the quality. And usually, if the file size so higher file size equals higher quality usually. Good. Any questions?
No, sir.
So you guys clear on all of this? Everything about file compression?
Pretty much.
Alright. Let's see. Do I have shucks, I have another one. Is it possible for us to do a class tomorrow?
Yep. For me.
Nope.
In the afternoon or morning?
Nope.
Alright. What would Monday? Monday's a holiday. That's a 1 hour.
Sure.
Sir,
Sure.
even though.
Janai, what you said?
Sure.
Okay. Alright, we can plan a day.